Hello, my name is Holly Petrovich, and today we're going to be talking about how to recognize saturated and unsaturated hydrocarbons. And this is for the course Chemistry 1093. It's important to understand the difference between saturated and unsaturated hydrocarbons because the structure of the hydrocarbon is going to determine what the properties of the hydrocarbon are. And one of these big properties is its flexibility. So our flexibility of the hydrocarbon affects the way the fluid mosaic model works. And finally, the hydrocarbons affect the biology of an organism and have an important role in their thermoregulation. So this is on a cellular and a broad scale. So our learning goals for today are to be able to identify the difference between saturated and unsaturated hydrocarbons, understand what saturated and unsaturated fats are, and understand why this concept is important in biology. So we'll start with our saturated hydrocarbons. These are our non-cyclic carbon frameworks that contain only single bonds and no pi bonds. These are also called alkanes. So the reason that they're called saturated is because they have only single bonds and no double bonds or ring structure, which means they are quite literally saturated with hydrogen. And them being saturated with hydrogen is going to be why they are more flexible than their unsaturated kin because of the lack of their pi bonds. So our unsaturated hydrocarbons, these hydrocarbons are going to be ones that contain a pi bond or have a ring structure. They're called unsaturated because the pi bonds create a potential for them to have more hydrogens if they had no pi bonds. These unsaturated hydrocarbons also have a degree of unsaturation. So the degree of unsaturation is the number of pi bonds the hydrocarbon has. So an alkene have one or more double bonds, and an alkyne have one or more triple bonds. And these bonds reduce the flexibility of the hydrocarbon and therefore are less flexible than their saturated hydrocarbon kin. And whenever we see a pi bond, we're typically also going to see a bend, and that'll come into play later. So we have our unsaturated fats. So we have two types. We have monounsaturated or polyunsaturated. So our monounsaturated are going to have a single degree of unsaturation, and our polyunsaturation are going to have more than 1 degree of unsaturation. And the double bond is again going to create a bend, and this reduces flexibility. So our two examples are oleic acid and linoleic acid. So our linoleic acid is going to be our polyunsaturated, and our oleic acid is going to be our monounsaturated. So for our fatty acids and phospholipids, where our saturated and unsaturated fatty acids come into play. So we have one saturated and one unsaturated fatty acid tail, and this creates the hydrophobic portion of the phospholipid. So we have one unsaturated fatty acid tail. It's going to be monounsaturated, and our hydrophilic component is going to be made up of a phosphate and glycerol. So again, we have a hydrophilic portion and a hydrophobic portion. And this all together comes and makes a phospholipid that is amphiphilic, okay? And this structure is going to play a large role because it's going to be the basic structure for our cell membrane. Our cell plasma membrane will help control the fluidity of the membrane. So these phospholipids are going to come together, and they're going to have their hydrophobic tails face each other. This is going to create a hydrophobic interior and a hydrophilic exterior, and this is going to create our phospholipid bilayer. So our phospholipid bilayer is going to be described in our fluid mosaic model, which describes the structure of all cell plasma membranes. So the hydrocarbons therefore play a really large role in our cellular makeup, and if we did not have unsaturated and saturated hydrocarbons, we would not have this fluid mosaic model here. So on a broader scale, temperature has a large effect on cell plasma membranes, and the unsaturated and saturated hydrocarbons help keep the membrane stable through the temperature changes. So in colder environments, the saturated hydrocarbons will become compressed, and the unsaturated hydrocarbons will actually fight this because they have bends. They have the bends in their double bonds. So this bend will create elbow room. So while we have some compression, these double bonds are giving us elbow room so that the membrane continues to remain fluid. So in many organisms like fish, in colder environments, they can alter the proportion of their unsaturated to saturated hydrocarbon chains in their fatty acids in response to colder temperatures so that they can keep their membrane quite fluid. So in summary, we learned the difference between unsaturated and saturated hydrocarbons. unsaturated and saturated fats, degrees of unsaturation, types of unsaturated fats, what a fatty acid and phospholipid are, and what this means for organisms as their plasma membranes respond to temperature. So I hope you learned something today, and thank you very much for listening.